Hello viewer, in this session we will discuss concepts on averages, mixtures and alligations. Now the best way to learn averages, mixtures and alligations is not through any sort of a concept or a theory, so to say, but by taking an example and actually trying to solve that example using a traditional approach and then looking at a much more simpler way of doing solving these questions using the concept of alligations. Now just to give you a very quick overview, a mixture is nothing but a mix of two different let's say ingredients as such, or two different mixtures itself. So if you're looking at something that's if you're looking at, let's say, two liquids, let's call those liquids A and B. If you have two liquids A and B, each liquid has, let's say, milk and water. It's not a very nice way to actually look at things because this is diluted, but anyway, let's say that each of these has milk and water in it. Then this A by itself can be called a mixture because it is a combination of two components. So A and B by themselves are what we call as simple mixtures. But let's say you combine A and B and you make a much more larger mixture. That's when you call that mixture as a compound mixture. So irrespective of what mixture, whether simple or compound, we will sort of stick to a very basic definition or a basic terminology. Let's call them mixtures. Now alligation is something that we'll come to at a little later stage. Let's try to understand this concept with a very traditional basic example. Now what you see on your screen is an example that says that if the arithmetic mean of the weights of boys in a class is 50 kilograms and that of girls is 40 kilograms, and the arithmetic mean of the weight of the entire class is 46 kilograms, then what is the ratio of the number of boys to that of the girls? Now, since we do not know the number of boys and the number of girls, let's call them B and G. So your class has a total of B plus G students. Now, traditional way of solving this question, this is the same approach that we have actually used in your class on statistics also, where we've used this concept of weighted average. That's exactly what we will use here also, and then we will actually move on to see how to use a much more simpler way of tackling it. That's nothing but your concept on alligation. So let's first understand this using a weighted average approach. If there are B boys in the class, 50 being the arithmetic mean of B boys, the total weight of B boys should be 50B. Likewise, the total weight of G girls should be 40G. This should be the total weight of your entire class. Since this is the total number of students in your entire class, total weight by total number of students should give you the arithmetic mean of the weight of your class, which is nothing but 46. So let's cross multiply. So what you have is 50B plus 40G is equal to 46B plus 46G. Bring like terms to one side, so what you have is 4B equals 6G, or B upon G is 6 upon 4, which is 3:2. So the ratio of the number of boys to that of the girls is 3:2. This is your traditional weighted average approach. Now what alligations tell you is that alligation is nothing but a reverse approach of weighted average. Instead of even assuming certain unknowns like B and G and then framing equations and then solving the equations and finding the ratios, we simply use this reverse weighted average method to quickly arrive at the solution in just one step. Let's see how we do that. Now, using this alligations method or concept, what we do is we write boys and girls, the average weight is 40, 50 and 40 in this manner, and we write the average weight of the class in the middle. Then what we do is we find the difference of these two values. 50 difference 46, we write this value here is 4. And then we find the difference of these two values and write that value here. 46 difference 40 is 6. So this gives you the ratio of the number of boys to the girls. If you quickly remember, this is exactly the value that we got using a traditional approach. But using this concept of alligations, it's just one simple, very elementary arithmetic calculation, just finding the difference and then finding the ratios. Now, what exactly happened here? If you have to understand it in a logical fashion, now understand that a little while back when we were using the weighted average approach, what we did was this. What we had was something like 50b plus 40g over b plus g equals 46. And then we said when we cross multiply and subtract them, what we get is 50 minus 46 times b equals 46 minus 40 times of g. Or what we got is b upon g is nothing but 46 minus 40 over 50 minus 46. This is what we've got, which led to the ratio of 3:2 or 6:4. Now notice that it is exactly the same concept, but it's done in a reverse fashion. In other words, we have not done any of these steps, but we straight away jumped to this step using this approach. So notice that on your left hand side, how did we get the 6 here? 6 was nothing but the difference of 46 and 40. That's your numerator part. That's your numerator that denotes the number of boys. Likewise, your right hand side is your denominator part, which denotes the number of girls. That's why we wrote it under girls here, which was nothing but difference of these two values. So 50 minus 46. So that's how you get your ratio as 3:2. So all these steps are not required. All you have to do is write your values in this fashion, find the difference, jump to this step directly, and you have your ratio here. Now, just a word of quick caution here. Make sure that when you're finding the difference, remember difference is always positive. You don't have to worry about how come 40 difference 46 was 6 and not minus 6. And difference is always positive. It's always greater value minus lesser value. Anyway, now what you need to remember here is this point. Whatever values you take here, either you take boys here or you take girls here, remember that if you're asked to find the value, the ratio of the number of boys to that of the girls, as per this concept, since left hand side was boys and right hand side was girls, we've got a ratio of boys to girls here. But if you'd written it in a different fashion, you would get the ratio of girls to boys. That's what you have to keep in mind as to what you're taking on your left hand side. Whatever you take on your left hand side automatically becomes the numerator of your ratio. And likewise, what you take on your right hand side becomes the denominator of your ratio. That's what you have to remember and keep in mind. We'll also look at understanding this with the help of a simple formula, but before we use that formula or introduce you to that formula, let's look at another example.